Hello everyone. In this lecture, I'm going to show you how to calculate the problems by using method of images. For this purpose, here I am considering a plane conducting sheet which is earthed. By earthed, what I mean to say is it is maintained at zero potential. So this is a plane conducting sheet, a conductor of infinite extent. Okay. So, and this horizontal axis I am taking as x-axis, and this vertical this axis I am taking as x-axis, this horizontal axis, and this I am taking as y-axis. This is y-axis, and this is x-axis, and perpendicular to this plane, this I am taking it as z-axis. The method of image is concerned with a conductor which is maintained at a constant potential, that is zero. It is earthed means the potential of this conductor, infinite extent, conductor of infinite extent is maintained at zero potential. Now, here at z, along the z-axis, at a distance d, a charge q is placed. We need to find out what is the resultant field at this point. Let me call this point as P, whose coordinates are given by x, y, and z. I wanted to find out what is the electric field as well as potential at this point due to this configuration. This is the actual problem. This problem is replaced or is converted into a problem like this. This problem is equivalent to a problem like this. If you take this as the z-axis, okay, if you take this as y-axis, and here I kept a charge q. Method of image, according to this method of image, what I can do is I can replace this earthed conductor with a negative charge, or I call it as image charge, image of this charge q at a distance. If distance from here to here is d, then from the laws of reflection in optics, object distance and image distance are same for a plane mirror. So it is going to work like a plane mirror, because of which distance from origin to this image charge also is d only, because of which this coordinates of this point are 0, 0 and minus d. Okay, so this problem is equivalent to this problem. I'm not going into the technical details how this problem is equivalent to this problem, what is the physics behind this. That is also very simple only, but I'm not going into that one. My every aim is to apply a known concept. Okay, so now I wanted to find out the strength of electric field as well as potential at this point P, whose coordinates are given by x, y, z. That is a general point I'm considering. So potential at P is contributed by both this charge q, real charge, and image charge minus q. So first I am writing down the expression for the real charge, that I am calling it as, this is positive charge, V plus is equal to what you can write, 1 divided by 4 pi epsilon naught into q divided by, distance from here to here is how much? Yes, x square plus y square plus z minus d whole square whole power 1 by 2. How I wrote it? Because we know the coordinates of this point. What are the coordinates of this point? 0, 0 and d, and coordinates of this point are x, y, z, and I used the expression for distance between 2 points, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, and we got this expression. Next, I'm going to write down the expression for potential due to this negative charge. That is, V minus is equal 1 by 4 pi epsilon naught into, this is minus q, so you should write it as it is, minus q divided by distance from this point to this point. How much it is? X square plus y square plus z minus of minus d is z plus d. So z plus d whole square whole power 1 by 2. Okay, so this is the expression for potential due to positive charge at this point and potential due to this negative charge or the image charge at this point. Therefore, total potential at P is contributed by both positive as well as negative charges. That is equal to 1 by 4 pi epsilon naught. Q by 4 pi epsilon naught I am taking common. 4 pi epsilon naught I am taking common. So remaining terms we can write as it is. 1 divided by x square plus y square plus z minus d whole square whole power 1 by 2 minus 1 divided by x square plus y square plus z plus d whole square whole power 1 by 2. This is the expression for resultant potential at point P due to this charge and this earthed conductor. Okay, now next I am going to calculate what is the strength of the field at this point P. Again I am coming back to this situation only. This is point number 1. Point number 1 is about potential. Next I am writing point number 2, which concerns with field at point P. Therefore potential a field at point P E plus, that is due to this positive charge, is given by 1 divided by 4 pi epsilon naught into Q divided by R square. R square is how much? X square plus Y square plus Z plus D whole square. And similarly E minus E is how much? 1 by 4 pi epsilon naught into minus Q divided by X square plus Y square plus, this is Z minus D, sorry I wrote it plus Z minus D, this is Z plus D whole square. Therefore total electric field at point P is given by EP is equal to E plus due to positive charge plus E minus, that is negative charge, that is equal to, what is the value of E plus we got? I am taking Q common. Q divided by 4 pi epsilon naught into 1 divided by x square plus y square plus z minus d whole square minus, because this is negative charge, 1 divided by x square plus y square plus z plus d whole square. This is the overall expression for electric field at point P due to this charge and this earthed conductor. Next thing is, what is the force between these two charges? That is point number 3. Third point, force. Force between these two charges is given by Coulomb's inverse square law. F is equal to, what you're going to write, I'm talking about the magnitudes only, okay? F is equal to, what you're going to get, 1 divided by 4 pi epsilon naught into Q1 is how much? Q. Into Q2 is how much? Minus Q. Divided by distance between these two is how much? 4d square. Simple. This is the expression for force between these two charges. And third and fourth thing, and very, very important thing that I'm going to talk about is the energy of the system. What is the energy of the system? This is the point at which everybody will do a mistake. Okay? Because I said this is alike, but I did not say it is the same configuration. This configuration are not same. This is alike to some extent. But when it comes to this energy of the system, if you do as it is, like expression for the potential energy of the system is given by U is equal to 1 divided by 4 pi epsilon naught into Q1 is Q, Q2 is minus Q divided by separation between these two is how much? D plus D, 4D. This is wrong. This is absolutely wrong. Why this is wrong? Because potential, if you wanted to talk about the energy of this system, okay, instead of doing this, I am proceeding by standard method. What is the standard method? Work done in bringing the charge from infinity to this point. So for mathematical simplicity sake, I'm bringing the charge along the z axis only instead of bringing in an arbitrary direction. Okay, so that only I'm doing. Therefore, work done by external agent, WE, external agent is equal to, okay, what is the expression for work done by external agent? I assume that this charge is at a distance, arbitrary distance z from this plane. Okay, I'm writing down the expression. That is, I'm work is equal to what you can write, F external dot dr bar only, dw is equal. Therefore, total work done by external agent is equal to what I can write. First, I should write down the expression for external, because electrostatic force is negative, so external agent force should be opposite to this one, because of which it is positive. That only I am writing. 1 divided by 4 pi epsilon naught into q square divided by arbitrary distance. I am taking it as z, so I should replace this d with z, 4 z square dot dz. This is the expression for work done, dw. Therefore, total work done by external agent. Therefore, W external is equal to what I can write, 1 by 4 pi epsilon naught q square, for everything is constant. I am putting it outside. Okay, 1 by 4 pi epsilon naught into q square divided by, this is 4, I am pulling it outside, summation over, from where I am bringing it, from infinity, where potential is 0, from infinity to the location D, into 1 by z square dz. This is the expression. That is equal to, okay, what I can write, 1 divided by 4 pi epsilon naught into q square divided by 4 into this integral value is how much, z power minus 2 plus 1. That is z power minus 1 divided by minus 1. So minus 1 divided by z I will be getting. Here I did a mistake. U is equal to potential energy. Distance from here to here, it is d plus d is 2d. This is not 4d. Okay, so that correction you do it here. 2d. Okay, now write down. Therefore, work done by external agent is equal to how much we got? 1 divided by 4 pi epsilon naught into minus q square divided by 4 into z. Okay, therefore potential energy U is equal to what you can write, change in the potential energy is equal to work done by external agent, or work negative of change in potential energy is work done by external agent. Final minus initial if you do it. Okay, final minus initial if you do it. Okay, final potential energy is how much, this much. Initial potential energy when it is at infinity is 0. So altogether you will be getting potential energy, final potential energy U is equal to minus q square divided by 4 pi epsilon naught into 4z. So observe this. This is 4z, this is 2z. Why this discrepancy? Here it is 2, this is 4. That means actually if you calculate by this, you should divide it by 2, then only you will be getting this. Actually this is the right answer. This is wrong answer. Why this is wrong? Because here you should be very careful. While bringing the charge from infinity, okay, the energy is associated with upper half of the plane only. This above z is equal to 0 only is associated with some energy, field energy. There is no this charge which is below this plane, or this image charge does not contribute anything to the energy about this plane. Why? Because this image charge is not a real charge. It is an imaginary charge. An imaginary charge cannot produce a real field. So because of which the energy, field energy is produced by the charge that is existing above the plane of the, what you call it as, above this conducting plane only. This is not contributing, because of which here we calculated by taking into the consideration the field produced by this as well as this. Okay, so that's why we are getting this one as double of this one. So either you half if it, you divide it by half, or you should proceed by this, or you should keep it in your mind that always if you calculate the energy by this method, okay, you are including the field energy by upper half plate and low upper region as well as lower region. Actually, the energy is contributed by upper region only, because this is imaginary charge, because of which this two factor difference is coming. So you should not proceed by this way, you should proceed by this way, or you proceed by this way but you should divide it by 2. Anyway, you will be getting the same answer. This is the overall thing regarding charge in front of a earthed conductor.